Okay, so the next question that we had was this question over here, which is you want to find the derivative of px squared plus qx plus r over ax plus b. So again, you can use the u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So I can write this as the derivative of the first function, meaning d by dx of px squared plus qx plus r times this function over here, ax plus b. And of course, you know that by this I mean that I'm taking the derivative of this function. I'm taking the derivative of this function and then I'm multiplying it by this function. I think this way there is no ambiguity there. And then you have to write basically px squared plus qx plus r times times v prime times the derivative of d by dx of ax plus b. ax plus b over ax plus b whole squared. So you know that the derivative of this function over here is equal to px squared, which is 2 times px plus q times, and r is 0 basically, so times ax plus b minus px squared plus qx plus r times d by dx of ax plus b, which is equal to just simply a over ax plus b whole squared. So that is equal to 2 times apx squared plus ab plus 2 times bpx plus aq plus aqx plus qb minus basically multiplying a by this is apx squared plus aqx plus ar over ax plus b whole squared, which is equal to 2apx squared plus 2bpx plus aqx plus qb minus apx squared minus aqx minus ar over ax plus b whole squared. Now 2apx squared minus apx squared is equal to apx squared so 2apx squared minus apx squared is equal to apx squared 2bpx and so I can write this as 2bpx and aqx, negative aqx you can cancel out, plus qb plus minus ar over ax plus b whole squared. So that's basically the derivative of this function, for example, number 9. apx squared plus 2bpx plus bq minus ar over ax plus b whole squared, for example. Now the next question that we have is a over x raised to the power 4. A over x raised to the power 4 minus b over x squared plus cos x. Okay, so the next question that we have here is this one. So if you want to take the derivative of this function, d by dx of this function, basically you can write it as d by dx of you can write it as d by dx of a over x raised to the power 4 minus d by dx of b over x squared plus d by dx of cos x. So then since basically a and b are constants, basically in the quotient rule we said that if you had u divided by v whole prime is the same thing as u prime times v minus u v prime over v squared. Now since d by dx of a, which is u prime here, is equal to 0, so then you can forget about this part and just you basically calculate this part. So the d by dx of a divided by x raised to the power 4 is equal to negative 8 times d by dx of x raised to the power 4 over x raised to the power 4 whole squared, which is equal to negative 8 times 4x raised to the power 3 over x raised to the power 8. So that is the same thing as negative 4a x raised to the power 3 over x raised to the power 8, which is the same thing as negative 4a over x raised to the power 5. Negative 4a over x raised to the power 5. So the derivative of this part is negative 4a over x raised to the power 5. Now d by dx of, for example, d by dx of b over x squared is equal to again the same story, negative b times d by dx of x raised to the power 2 over x squared whole squared, which is equal to negative b times 2x over x raised to the power 4, which is equal to negative 2 times bx over x raised to the power 4, and and over here you have x raised to the power 3, so you have negative 2b over x cubed. So that's minus negative 2b over x cubed. And you know that d by dx of cos x is negative sin x. So then you have basically negative 4a. Let me write it this way. You have negative 4a over x raised to the power 5 plus 2b over x raised to the power 3 minus sine x. So question number 10 is negative 4a over x raised to the power 5 plus 2b over x cubed minus sine x. Question number 11 is 4 times square root of x, 4 times the square root of x minus 2. And you want to find the derivative of this function. So you know that this is equal to d by dx of 4 square root of x minus d by dx of 2. So you can basically d by dx of 4 square root of x is equal to d by dx of 4 times x raised to the power 1 by 2. 4 times x raised to the power 1 by 2, which is basically 4 times 1 by 2 times x raised to the power 1 by 2 minus 1. So 1 by 2 minus 1 is basically negative 1 by 2. So that would be x raised to the power negative 1 by 2. Which is the same thing as so. And 4 and 2 you can cancel out. So you have 2 times x raised to the power negative 1 by 2. Which is the same thing as 2 over x raised to the power 1 by 2. Which is equal to 2 over the square root of x. So, so then d by dx of 4 times square root of x is equal to 2 over the square root of x. So over here you can write 2 over the square root of x. Of course there are all kinds of formulas for these, but in the beginning we will have to basically do a couple of derivatives by hand, and then we will be able to use those formulas. We need to derive them basically. I don't know really what happens in the next book, but I suppose you could probably even use these as formulas if you want to, and derive a couple of things for yourself, that the kind of things that you think you might need in the future, something like that. But I mean, always whenever you're working on something, for example, you're working on physics, or you're working on some branch of physics, for example, I don't know, electronics or something like that, usually the kind of things that you need along the way, you will know it. You don't need to really plan that ahead. You will know it once you get to the material that you want to read. So that's really nothing to really worry about. So, and d by dx of 2, of course, is equal to 0. So the derivative of this function is 2 over square root of x. Number 11 is 2 over square root of x. Number 12 is you want to find d by dx of, for example, ax plus b whole raised to the power n. So this is a little bit tricky, because, for example, if you had for example, ax plus b raised to the power 2, I would raise it to the second power, but over here I need to use the binomial theorem. And for example, you know that you know that a plus b, for example, raised to the power n is equal to basically n combination 0, a raised to the power a raised to the power n, a raised to the power b raised to the power, for example, 0, I suppose. I have forgotten that actually. And then you have, for example, n combination 1, a raised to the power n minus 1, b raised to the power 1, plus n combination 2, a raised to the power n minus 2, b raised to the power 2, for example, plus all the way up to n combination n, a raised to the power n minus n, b raised to the power n, something like this. So if basically this is the expansion of this function over here. But then how we can calculate, for example, the derivative of this thing, I think we can try. So if I wanted to take the derivative of this, the derivative of this thing would be, if I want to take the derivative of d by dx of this thing over here, this would be equal to, let's forget about this part, the derivative of just this part. So for example, n combination 0 is equal to, you know what, basically you know how combination works, so it's n factorial over n minus 0 factorial times 0 factorial. That is n combination 0. Now if you have, for example, n combination 1, that is n factorial, n minus 1 factorial, and 1 factorial, and so on and so forth, all the way up to n minus n factorial would be again the same things, meaning that n combination r, is basically, as a general rule, is basically n factorial n minus r factorial times r factorial. Okay, so then based on this you can calculate any sort of combination that you might have. But now the problem is that, for example, suppose that I want to calculate d by dx of this thing over here. So n factorial, if I want to calculate the derivative of n factorial, it would be basically, for example, d by dx of n factorial would be d by dx of 1 times 2 times 3 all the way up to n. Which is just a bunch of numbers, multiplied together. It's a constant. So that means that d by dx of n factorial, is equal to 0. Right? So if this is equal to 0, then for example, the whole thing is equal to 0. I'll just come back and we'll work through this. Okay, so now there is a problem here, and the problem is that we have not written this properly. You see over here, I have basically what I want to differentiate is a times x plus b. Now this is the expansion of this over here is the expansion of a plus b raised to the power n. So I need to make some changes to this, and the changes that I need to make is that is that, let me just rewrite the whole thing. And of course, this is something that you can use all the time. So this is, I mean, it might take us some time to derive some formula for this, but otherwise you will be able to use it all the time. So I know that a plus b raised to the power n based on the binomial theorem is n combination 0 a raised to the power n, meaning a raised to the power n minus 0, b raised to the power 0. Okay. So then you have n combination 1, for example, a raised to the power n minus 1, b raised to the power 1. Then you have n combination 2, a raised to the power n minus 2, b raised to the power 2. Plus all the way up to, this goes all the way up to n, meaning you have n combination n, a raised to the power n minus n, b raised to the power n. So that's the binomial theorem. And it works based on the principle of based on the concept of combinations, because of that whole story of the Pascal, the Pascal's triangle. If you take a look at the Pascal's triangle, of course I cannot get into that sort of thing right now, but this is the binomial theorem, and based on the binomial theorem, the expansion of a plus b raised to the power n is going to be equal to this, where n combination n is equal to basically n factorial over n minus n factorial, n combination r. N combination r is equal to basically n factorial over n minus r factorial times r factorial. That is the binomial theorem. Now, based on this you can write ax plus b raised to the power n is equal to a n combination 0. So this is the first term. So the first term is ax whole raised to the power n minus 0, b raised to the power b, well, that's the same thing, b raised to the power 0. And then you have, after that you will have n combination 1, the first term ax raised to the power n minus 1 times b raised to the power 1, plus n combination 2, the first term ax raised to the power n minus 2, b raised to the power 2, all the way up to n combination n, ax, which is the first term, raised to the power n minus n, b raised to the power n, which I can write as basically n combination 0. Now n minus 0 is equal to n, so that's a times x raised to the power n, b raised to the power 0 is equal to 1. And then you have n combination 1, ax raised to the power n minus 1 times b, plus n combination 2, ax raised to the power n minus 2, b raised to the power 2, plus all the way up to n combination n, ax raised to the power n minus n is equal to 0, so that's ax raised to the power, basically that the whole thing would be 1, ax raised to the power, or raised to the power 0 is equal to 1. So I don't have to write it anymore, b raised to the power n. And so basically what I have is basically this thing over here. Now if I want to, this is ax plus b raised to the power n. Now if I want to take the derivative of if I want to take the derivative of ax plus b raised to the power n, I'll have to take the derivative of d by dx of basically d by dx of this whole thing, d by dx of this whole thing over here, which would be, for example, which would be the derivative of, for example, n combination 0, ax whole raised to the power n, for example, plus d by dx of n combination 1, for example, ax raised to the power n minus 1, plus all the way up to the d by dx of n combination n b raised to the power n. Okay. Now let's see how we can differentiate these functions, basically one by one, and I think then we will be able to find some sort of rule over here. So then what you will have is n combination 0, as we said, is basically n combination 0 would be equal to n factorial over n factorial times 0 factorial. So these two will be cancelled out. So this is equal to 1, some constant. So this is some constant. So that means that you are taking the derivative of, you're actually taking the derivative of, for example, 1 times a raised to the power n times x raised to the power n. This is an x, which is basically, which if you want to take the derivative of this thing over here, you can write it as a raised to the power n times x raised to the power n minus 1. So that's a raised to the power n times n times n times x raised to the power n minus 1, or you can write it as n a raised to the power n x raised to the power n minus 1. You can write it over here, n a raised to the power n x raised to the power n minus 1. Then I have the derivative of this thing over here, which is n combination 1, for example, ax whole raised to the power n minus 1. Now the derivative of this is basically n combination 1 is again n factorial over, for example, n minus 1 factorial times 1 factorial, right? Now if you want to, for example, simplify this, you can write it as basically n factorial is the same thing as 1 times 2 times 3 times 4 times 5 times all the way up to n, whatever n might be. N minus 1 and 1 factorial is just 1, so you don't have to think about that. Now n minus 1 factorial is basically 1 times 2 times 3 times 4 times all the way up to n minus 1. Okay, and so since you see that you have 5 over here, you have 4 before that, meaning that if you take this as n, this would be n minus 1. So n minus 1 must be before n. So that's n minus 1. So you can write this as 1 times 2 times 3 times 4 times 5 times n minus 1 times n. And then you can cancel out all of these things together. And so n combination 1 would therefore be n. N combination 1 would therefore be n. So you can write this as basically d by dx of, instead of n combination 1, I can write n a raised to the power n minus 1 x raised to the power n minus 1. Okay. Now you can see that n times a raised to the power n minus 1 is just some constant, right? So I can write this as the derivative of this would be, well, the constant times the derivative of this function, which would be equal to n times a raised to the power n minus 1 times n minus 1 times x raised to the power n minus 2. Okay, so I can write this as n times n minus 1 times a raised to the power n minus 1 times x raised to the power n minus 2. So instead of this, I can write n times n minus 1 times a raised to the power n minus 1 times x raised to the power n minus 2. And then you have, and then you can go for the, just to find some sort of rule over here. I want to go a couple more terms, see what happens. So for example, the next term over here would be d by dx of the term after this would be d by dx of, for example, n combination 2 ax raised to the power n minus 2 and b raised to the power, for example, well, there's supposed to be a b over here as well. There is supposed to be a b over here as well. The b we have forgotten. There is supposed to be a b over here as well. So the b is just, of course, the b is just a constant, right? The b is just a constant. So I can write it. So I can write this term as, I can just multiply b by the whole thing. I can write it as n times n minus 1 times a raised to the power n minus 1 times b times x raised to the power n minus 2. And over here, the next term would be this thing. Would be this thing over here. So you have n combination 2 ax raised to the power n minus 2b squared, and you want to take this the derivative of this. So you know that now n combination 2, for example, would be, n combination 2 is basically n factorial, n minus 2 factorial times 2 factorial, right? Times 2 factorial. So you can rewrite this as, n is just 1 times 2 times 3 times all the way up to n. And n minus 2 factorial is 1 times 2 times 3 times all the way up to basically n minus 2. And before n over here you have of course n minus 1, and you have n minus 2, and you have the 2 factorial over here, which is just 2 times 2. So I can simplify all of these terms with all of these terms, and so you have n times n minus 1 divided by 2. So this would be n times n minus 1 divided by 2. So I can write this as d by dx of n times n minus 1 divided by 2 times b squared times b squared times b squared times a raised to the power n minus 2 times x raised to the power n minus 2. Right? And so what that means is that a raised to the power n minus 2 is a constant, b raised to the power 2 is a constant, and these are all just constants. So the only part that you want to differentiate is basically this part over here. So then you can write it as basically the differentiation of this whole function becomes n times n minus 1 divided by 2 times b squared times a raised to the power n minus 2. And then the differentiation of this thing over here becomes n minus 2 times x raised to the power n minus 3, right? So I can write this whole thing as n times n minus 1 times n minus 2 divided by 2 times a raised to the power n minus 2 times b raised to the power 2 times x raised to the power n minus 3. That is the differentiation of the next term. So I can write this as plus basically n times n minus 1 times n minus 2 divided by 2, a raised to the power n minus 2, b raised to the power 2, x raised to the power n minus 3. So the next term that you would get after this term would be basically n combination 3, and then I want to basically calculate the next term after this as well. Okay, so now the next term after this, suppose we came all the way up to 1, 2, and 3, so 1, 2, and 3, so that is n combination 2. So now the next term after this is going to be basically n combination 3, ax raised to the power n minus 3 times b raised to the power 3. And if you want to take the derivative of d by dx of this expression, what you have basically is, again, basically a, b cube and n combination 3 are constants, and n combination 3, for example, is equal to n factorial over n minus 3 factorial, and 3 factorial over here. So then you can see that you can write this as 1 into 2 into 3 into all the way up to n, and then you can write this as 1 into 2 into 3 into all the way up to n minus 3, and then over here you have n minus 1, over here you have n minus 2, and over here you have n minus 3, and you have a 3 times 2 over here. You have a 2 times 3 over here, which is 3 factorial, or basically you can say 1 times 2 times 3. So so then you can simplify all of this with this over here, and then you can write this as n combination 3. You can write it as n minus 2 times n minus 1 times n over 1 times 2 times 3 over 1 times 2 times 3. So I can write this as the d by dx of basically n minus 2 times n minus 1 times n over 1 times 2 times 3 times a times b raised to the power 3, and that is actually a raised to the power n minus 3. That is a raised to the power n minus 3. That is ax whole raised to the power minus 3. So this would give you a raised to the power n minus 3, b raised to the power 3, and x raised to the power n minus 3. So you want to take the derivative of this over here. You want to take the derivative of this over here. So again, all of these are constants, so you don't need to bother about these. So you can write this as basically, and the derivative of this part becomes n minus 3 times x raised to the power n minus 4. So you can write this as n times n minus 1 times n minus 2 times n minus 3 over 1 times 2 times 3 over 1 times 2 times 3 times a raised to the power n minus 3, b raised to the power 3, x raised to the power n minus 4. So then basically I can write the derivative of the fourth term as this thing over here, plus n times n minus 1 times n minus 2 times n minus 3 over 1 times 2 times 3, a raised to the power n minus 3, b raised to the power 3, x raised to the power n minus 4. And then the last term that you have is n combination n plus all the way up to n combination n b raised to the power n, b raised to the power n, which is just some constant, and the derivative of this is going to be 0 because n combination is n. Basically, first of all, n combination n is equal to n factorial over n factorial times 1 factorial, which is just equal to 1. So that's b raised to the power n, some constant. The derivative of basically this is going to be 0. So you don't need to bother about this. But the term that comes before that is, of course, does contain some x. So the term that comes before this is n combination n minus 1, n combination n minus 1, basically ax whole raised to the power n minus 1, n minus n minus 1, and b raised to the power n minus 1, b raised to the power n minus 1, which is the same thing as n combination n minus 1, ax raised to the power, so n minus n minus 1 is equal to n minus n plus n minus n plus 1. That is n minus n plus 1. These two will cancel out, so you'll have to get just a 1 over here. A times x times b raised to the power n minus 1. So if you want to take the derivative of this, d by dx of this whole thing, then what you need to do is, first of all, n combination n minus 1 is the same thing as n factorial over n minus 1 factorial over n minus 1 factorial, times n minus 1 factorial. So again, n minus n plus 1 is equal to 1. So this is just 1 factorial, which is 1. So it's simply n factorial over n minus 1 factorial, which is basically 1 times 2 times 3 times all the way up to n minus 1 times n over 1 times 2 times 3 times all the way up to n minus 1. And when you And when you basically take when you calculate this, you'll get just n. So I can write this as d by dx of n times a, n times a times b raised to the power n minus 1. And the derivative of x is just x. So times x. So that is n times, instead of this you can write n. Then you have a, you have b raised to the power n minus 1, and then you have x over here. You have x over here. So then you have the derivative of this becomes basically this whole constant, which is n times a times b raised to the power n minus 1 times the derivative of x, which is equal to 1. So that is the derivative of your last term over here. So it is n times a times b raised to the power n minus 1. So that's basically the derivative of ax plus b raised to the power n. It is basically this thing over here. N times a raised to the power n, a raised to the power n, x raised to the power n minus 1, plus n times n minus 1 times a raised to the power n minus 1 times b times x raised to the power n minus 2, and then it just keeps going in the same way. So let me see if the answer is correct. Oh, it seems that you can take a couple of things out. We have an n over here, an n over here, an n over here, and some n over here. Okay, so suppose that I take I take n times a out. Okay, so suppose that I take n times a out. What I will get is basically a raised to the power n minus 1 times x raised to the power n minus 1. And then over here I will get n minus 1 times a raised to the power n minus 2 times b times x raised to the power n minus 2. And then over here I'll get basically n minus 1 times n minus 2 over 2 and a raised to the power n minus 3, b raised to the power 2, x raised to the power n minus 3, plus, so what I will get over here is n minus 1 times n minus 2 times n minus 3 over 1 times 2 times 3, a times a raised to the power n minus 4, b raised to the power 3, x raised to the power n minus 4. And then all the way up to b raised to the power n minus 1. Now this part over here, you should be able to write it as ax plus b raised to the power, this part over here, from here all the way up to here. This you should be able to write it as ax plus b raised to the power n minus 1, I suppose, because that's how they have written it. So the way that we can verify that, I'm going to write, I'm going to expand this thing and see what we get. Okay, so now let's expand this polynomial or this binomial. Let's see what we get. So our goal now here is to expand this and see if it looks anything like this, basically this expanded version of that binomial, starting from this point all the way up to this point. Okay. Now, if I write based on the binomial theorem, based on the binomial theorem, if I write ax plus b raised to the power n minus 1, that is the same thing as so basically, if you have, based on the binomial theorem, if you have, for example, a plus b raised to the power n, that is going to be n combination 0, n combination 0, for example, a raised to the power n, b raised to the power a raised to the power a raised to the power n minus 0, b raised to the power 0, plus, for example, plus n combination 1, a raised to the power n minus 1, b raised to the power 1, all the way up to n combination n, a raised to the power n minus n, b raised to the power n. That is the binomial theorem. So here your index starts at n combination 0. Okay. So what that means is that I suppose, I'm not really sure about this, but let's try to see if that's actually true. So I suppose you can write basically n, since here I'm starting with n minus 1, so I write n minus 1 combination 0. Let's see if that's the case. A raised to the power, so ax whole raised to the power n minus 1, and b raised to the power, for example, b raised to the power 0. Okay. And the second term would be n minus 1 combination 1, for example, ax raised to the power, ax whole raised to the power, for example, n minus 1 minus 1, so that's n minus 2, b raised to the power 1, for example. And then you have n minus 1 combination 2, for example, ax raised to the power n minus 3, and then you have b raised to the power basically 2, plus all the way up to so you have n minus 1 combination, I suppose n minus 1, because you cannot write n minus 1 combination, and that doesn't make any sense. N minus 1 combination n minus 1, ax raised to the power 0, basically b raised to the power n minus 1. I suppose that's how that happens. So then this is equal to n minus 1 combination 0. N minus 1 combination 0 is the same thing as if you had meaning that you have n minus 1 factorial over n minus 1 factorial over times 0 factorial, which is equal to 1. These two will be cancelled out, and this is equal to 1. So basically what that means when you say n minus 1 combination 0, when you say n minus 1 combination 0, what that actually means is that you have n minus 1 objects, and then you take 0 objects out of those n minus 1 objects. So there is only one way of doing that, meaning that you actually don't do it. So not doing it is just only one way of, there is only one way of not doing it, or taking 0 objects out of n minus 1 objects. So this is, of course, this is just a definition, and that is equal to 1. Okay. So n minus 1 combination 0 is equal to 1. So this is equal to 1, and this is a raised to the power n minus, so this is also equal to 1, and so you have basically n a raised to the power n minus 1 times x raised to the power n minus 1. And let's see if that's actually true. A raised to the power n minus 1, x raised to the power n minus 1. That this part is actually correct. There is no discrepancy between these two. Now, if you have, for example, n minus 1 combination 1, this is going to be equal to n minus 1, because when you write n minus 1 combination 1, that means that what that means is that basically you have n minus 1 objects, and you want to take one of those objects or you want to take basically one object out of those n minus 1 objects. In how many ways can you do that? So suppose that, for example, you have four marbles, for example. You have 4 marbles over here. You want to take basically one marble out of these 4 marbles, so that basically the only ways that you can do that is that first you can take this marble, and then you can take this marble, and then you can take this marble, or you can take this marble, right? So, and of course these basically if you took this marble or if you took this marble, these would be 2 different choices. So there are 4 distinct choices that you can make here. Out of 4 marbles, you can take 4 marbles over here. I mean, there are 4 ways of basically choosing one marble out of 4 marbles, meaning that 4 combination 1 is equal to 4, because 4 combination 1 is equal to basically 4 factorial over 4 minus 1 factorial over 1 factorial, the times 1 factorial. So this is basically simply 4 factorial, or I can write this as 3 times let me simplify this way. For example, you can write this as 1 times 2 times 3 times 4 over, this is 3 factorial, so that's 1 times 2 times 3 times 1 factorial, which is equal to 1. So you see that you will be left with a 4. So that means that there are 4 ways of taking one marble out of 4 marbles. Okay. And with the same logic, again, n minus 1 n minus 1 combination 1 would be just simply be equal to n minus 1. Okay, and we can of course calculate this, meaning that you can write n minus 1 factorial over n factorial times that would be basically, in the denominator you would get n minus 1 minus 1 factorial times 1 factorial. So, and the formula for this is n combination r is equal to n factorial over n minus r factorial times r factorial, right? This is the general formula for these combinations. So then basically this is the same thing as n minus 1 factorial over n minus 2 factorial, and 1 factorial is just 1. Now what happens is that so n minus 1 factorial is the same thing as basically 1 times 2 times 3 times all the way up to n minus 1, all the way up to n minus 1. Now n minus 2 factorial is the same thing as 1 times 2 times 3 times all the way up to n minus 2. Now when you write, for example, n factorial, that is the same thing as 1 times 2 times 3 times all the way up to n. Okay, and before n, of course, you will always have n minus 1. Before n minus 1, you will always have n minus 2. Before n minus 2, you will always have n minus 3, and so on and so forth. So before n minus 1, I have n minus 2, right? So now if I write this way, I can simplify all of these terms with all of these terms, and I will be left with n minus 1, which is exactly what I said over there. So then what that means is that n minus 1 combination 1 is equal to just simply n minus 1. So that is n minus 1. And then here you have a raised to the power n minus 2, x raised to the power n minus 2, right? Now the next thing that we have here is n minus 1 combination 2, for example, and this whole thing over here. So you have n minus 1 combination 2 times ax whole raised to the power n minus 3, b raised to the power 2. Now n minus 1 combination 2 becomes a little bit more complicated, and I mean practically what it means is that suppose you have 4 marbles, okay? You have 4 marbles, marble number 1, marble number 2, marble number 3, and marble number 4. Out of these 4 marbles, you want to take 2 marbles at a time. In how many ways can you do that? And that is the meaning of basically, for example, 4 combination 2, right? And how many ways can you do that? So first I can take 1 and 2. Second, I can take 1 and 3. Third, I can take 1 and 4, right? Then I can come back over here and I can say that, okay, so now I can take 2 and 1. Then I can take 2 and 3. Then I can take 2 and 4. Now there is no problem here, except that 2 and 1 and 1 and 2 are exactly the same group of marbles. So I'm not supposed to count this twice. So I have to get rid of this one because these two are exactly the same. So now I can come to 3 basically. So then I can say that, okay, so I take 3 with 1. I take 3 with 2. I take 3 with 4, right? And of course 3, you cannot take it with 3 because it's just one marble. You want to take 2 marbles at a time. Now 3 with 1 is the same thing as 1 with 3. So you have to cross that out. 3 with 2 is the same thing as 2 with 3. So you have to cross that out. So this remains here. And then you can say that, okay, now I want to start with 4. So I take 4 with 1. I take 4 with 2. I take 4 with 3. And of course 4 with 3 is basically something that I have done once, so I don't want to do it again. And this is 2 and 4, this is 4 and 2, I don't want to do this again. And this is 4 and 1, so that I have done this over here as well. So the only ways that I can do this is basically 1 way here, 2 ways here, 3 ways here, 4 ways here, and 5 ways here, and 6 ways. 6 ways. So the question that I'm asking here is, in how many ways, if you had 4 different distinct marbles, 4 different distinct marbles, could you pick two marbles out of them in such a way that you did not make any repetitions. And so the answer to this question is 4 combination 2. It is calculated as 4 factorial over 4 minus 2 factorial, 4 minus 2 factorial times 2 factorial, which is the same thing as 4 factorial over 2 factorial times 2 factorial, which is the same thing as basically 1 times 2 times 3 times 4, and 1 times 2 times 1 times 2. This is 2 and 2, and this is 4, which is 6 ways. 6 ways, and 1, 2, 3, 4, 5, and 6, exactly 6 ways. So that's basically, for example, 4 combination 2. Okay, so that what I basically I showed you. I showed this in order to show you that basically when your R over here is not 1, then it gets a little bit complicated, and then you have to basically then you have to calculate the whole thing. You cannot just say, you cannot, for example, over here I said that n minus 1 combination 1, of course its n combination is n minus 1, right? But when you have n minus 1 combination 2, then you cannot just do it in your head just like that. So what that means is that then n minus 1 combination 2 ax whole raised to the power n minus 3 times b squared is going to be equal to basically n minus 1 combination 2 is equal to is equal to n minus 1 factorial over n minus 1 minus 2 whole factorial over 2 times 2 factorial, which is equal to basically n minus 1 factorial over n minus 3 factorial times 2 factorial, which is equal to basically what that means is that this is this is 1 times 2 times 3 times all the way up to n minus 1, and over here you have 1 times 2 times 3 all the way up to n minus 3, and then you have a 2 factorial over here, which is just a 2, or you can write it as basically 1 times 2, right? So now n minus 1, before n minus 1, of course there is always n minus 2. Before n minus 2 there is always n minus 3. So then n minus 3, all of these terms can be cancelled out with all of these terms. So this would be equal to n minus 2 times n minus 1 over 1 times 2, right? So you can write this as n minus 2 times n minus 1 over 1 times 2 times a raised to the power n minus 3, b raised to the power 2, and x raised to the power n minus 3. So that is basically that term over there, which is, if you look at that term, you will get the same thing, n minus 1 times n minus 2 divided by 2, a raised to the power n minus 3, b raised to the power 2, x raised to the power n minus 3, right? So then I can write this over here. I can write this over here as well, the same thing basically. N minus 1 times n minus 2 over 2, basically a raised to the power n minus 3, b raised to the power 2, x raised to the power n minus 3. And then the last term over here would be, if you have, so what we are doing here, we are expanding this, and so your last term would be n minus 1 combination n minus 1. So this would be basically n minus 1 combination n minus 1. Now what this means, let's talk about this as well. Okay, so now basically to understand what this last part over here, for example. So for example, when you have n minus 1 combination n minus 1, so what that means is that you have, let's say that for example n minus 1 is equal to, for example, 4, right? That means that you have four for example 4 marbles over here: marble number 1, marble number 2, marble number 3, and marble number 4. Now the question that you want to ask yourself is, how many ways are there to pick 4 marbles at a time from 4 marbles? So how many ways are there to pick 4 marbles at a time? 4 marbles at a time from 4 marbles. And the answer, of course, would be just one way, because you have 4 marbles and you want to pick 4 marbles, so you have to pick all of them. So 1, 2, 3, and 4, you have to pick all of them, and there would be only one way of picking, basically of selecting these 4 marbles out of the 4 marbles. So that's equal to 1. And of course, if you want to calculate this, of course, it would be n minus 1 factorial over n minus 1 minus n minus 1 whole factorial times n minus 1 factorial, which is equal to n minus 1 factorial over, now over here you have n minus 1 minus n plus 1. So these two you can cancel out, these two you can cancel out. That's 0 factorial, which is equal to 1. So this is just equal to 1. And then you have n minus 1 factorial. So these two you can cancel out and you will get a 1. So there is only one way of selecting 4 marbles out of 4 marbles. So then this part over here, n minus 1, basically let me write this as plus all the way up to n minus 1, combination n minus 1 is just equal to 1. A times x raised to the power 0 is equal to 1. So that's equal to 1, and then you have b raised to the power n minus 1. So now if I go back to this part over here, it was basically a raised to the power n minus 1, a raised to the power n minus 1, x raised to the power n minus 1 plus n minus 1 times a raised to the power n minus 2 times, there is supposed to be a b over here as well. The b is there, so b is there, of course. So there is a b over here as well, and then you have basically the third term is n minus 1 times n minus 2 divided by 2, a raised to the power n minus 3 b squared x raised to the power n minus 3, and then the last term is b raised to the power n minus 1. So this thing is equal to ax plus b whole raised to the power n minus 1. So then I can write this as I can write this whole thing from here all the way up to the end. I can write it as NA times AX plus B raised to the power n minus 1. So what that means is that d by dx of ax plus b raised to the power n, so that means that d by dx of ax plus b whole raised to the power n is equal to n times a times ax plus b whole raised to the power n minus 1. And that is something that you can use all the time. This is actually one of the formulas that you can use in calculus all the time. So of course I kind of knew that it would take us a long time to go through this problem, but of course mathematics is all about, well, doing mathematics. If you don't have the time or if you don't have the patience, it just doesn't make any sense to do it. You cannot rush it. So that's basically that. This was question number 12. Now in the next video we will talk about the next question, which is question number 13.